So in this example of a monohybrid cross, what I've chosen is a frog with skin colour of green or yellow. So this is basically just to show that regardless of the species and regardless of what the characteristic is, it doesn't really matter how you do it, and it doesn't matter what the feature is. This procedure for this is still the same. So in this example, it says to calculate to the F2 generation the results of the following cross. So a green frog with 2 capital G's, therefore homozygous because it's 2 of the same, and dominant because it's a capital letter. And cross it with a yellow frog, homozygous, 2 of the same, recessive because it's a small letter. Right? So we start off with our P generation, the parental generation. And we start off with the first one they listed. So phenotype of that first frog is green. And the genotype of that frog is 2 capital G's. The yellow frog, yellow is its phenotype, and 2 small g's is its genotype. Now in this cross, in terms of the potential genotypes you could have in total, you can have 2 capital G's. It's got a capital, therefore it would be green. Capital G, small g, which is heterozygous. That would also be green because it's a capital, it's a dominant allele. And then 2 small g's. There is no capital, therefore it can't be green. It can only be yellow. Okay, so when we cross this P generation, we cross the green and yellow together. We do a Punnett square to show this. So we put one parent, and I'm choosing the green one to go on the top, and one parent, the yellow one, to go on the side. So we do the Punnett square as usual. Capitals go first, and then small letters. And what we discover is then, in F1, their genotypes are all the same. So any child that they potentially could have would always have capital G, small g. Their phenotype then, what they would look like, we use our genotype to figure that out. So if we look at it, we have a capital G, and therefore that would make them green, regardless of what their other allele is. So if they have a capital G, it makes them green. So if we want to figure out what the F2 generation is, we cross 2 of the F1 together. So we do a Punnett square. One parent goes up here, one parent goes here, and we do the cross as usual. So in this cross, in terms of genotypes, we have 1 homozygous dominant. We have 2 heterozygous, and we have 1 homozygous recessive. Okay, and that would be our genotype ratio. Now we look at our phenotype then. This person has at least 1 capital G, and therefore they'd be green. And so do these 2 people. They're going to be green. So therefore, in total, you're going to have 3 green frogs. Now this one, there are 2 small g's, and therefore they're going to be yellow. They cannot be green because they don't have a capital letter. So that's 1 yellow. So in terms of the chances of them having a green or a yellow child, a green or yellow frog, it'd be 3 out of the 4 in total. So these 3 would all be green out of the 4 potential genotypes they could have, 4 potential phenotypes. So it'd be a 75% chance of green, or 3 out of 4, or 25% chance which is 1 out of 4, 1/4.